Okay, so what I'm going to do is I'm going to go over some of the questions from the revision worksheet. Now, I've posted all the solutions for the whole worksheet on Schoology yesterday, and they're posted on OneNote now. I moved them over to OneNote as well. I couldn't schedule them to go up on OneNote, whereas I could schedule it for Schoology, and I didn't want to put it up straight away. But what I'm going to do now is I'm going to go over some of the questions, and I'm going to focus on the word questions because they were the ones maybe that were causing issues or anxiety for people today. So I'm going to focus on the word ones from here. The rest of them, the solutions are posted there in Schoology. It's a lot of kind of equations, which we did in a previous video, so you can look back at that video as well. But I'll focus on kind of the word ones at the end. Most of them are all exam ones. This example here, we have question 13, again an example from 2022, and then we have this last one, that was an example, which was an example as well. So starting off, we'll look at question 11. So John deposits 8,000 in an account that pays 4% PA, so per annum, and the model A equals P of 1 plus IET describes the growth of the investment over time, where P is the present value and I is the rate of interest, expressed as a decimal, T is the period of time in years. Okay, so a good bit of information there. We have this formula, which we saw in class one of the days. We're told how much he invests, we're told the interest rate, and we're told what each of the letters stands for. Important points, I suppose: interest expressed as a decimal, time in years, things like that. Okay, so we're taking note of all of this. The first part says, explain why A is equal to 8,000 multiplied by 1.04 to the power of T describes the growth of John's investment over time. Okay, so if we think about it, what they've told us is that John's putting €8,000 into an account, and that account's going to pay 4% per annum. Okay, what we mean by that is that each year he gets 4% added on in interest. So in the first year, he has 8,000 and he's going to get 4% added on. And to do that quickly, we can multiply by 1.04. That's the same as getting 4% and adding it on. Okay, because 4% is 0.04. And if we think about it, we're essentially getting 104%, which as a decimal is 1.04. Okay, it's called a multiplier. So multiply by 1.04, and that will give us the amount of money for 1 year. For the next year, we're going to take that answer and we're going to multiply it by 1.04. Okay, so essentially what we have is now it's 8,000 by 1.04 squared. Then for the third year we do the same, for the fourth year we do the same, for the fifth year, and so on and so forth. And what we end up with is that it's 8,000 multiplied by 1.04 by 1.04 and multiplied by 1.04 for however long we're considering. Okay, with this being T, the time. And we know that if we multiply something by itself T times, that's the same as having just to the power of T. So that's where the formula comes from, and that's kind of the idea they're trying to get at with that one. Anyway, we're going to focus on the further ones. Okay, these context ones sometimes can just be tricky to get your head around. What will the value of John's investment be in 3 years' time? So let's focus first. So 3 years' time. So we know T is equal to 3. We want to find that value A. We want to find A. So we're looking for A when T is equal to 3. Okay. P is the present value. So P is going to be the original value, which is 8,000. So we're looking for A. When we have 8,000, we know the interest was 4%, so we're back with this formula we had originally, and we're going to put 3 there, okay? And then it's just a matter of working that out. So let me just see here. So we can just input that into our calculator fairly easy. 8,000 multiplied by 1.04 to the power of 3, and we get an answer of 8998. And let's see, 91. So 8,998 and 91 cents. Okay, so that's the value of John's investment in 3 years' time. Then we're asked, how long will it take for John's money to double? So essentially, how long will it take for him to have 16,000? So we're trying to find T. Okay, so 16,000 is equal to, same formula, 8,000 by 1.04 T. Okay, this is one like the ones we saw today. What we want is to get to a point where we have this 1.04 T. And once we're there on its own on the right hand side, nothing in front of it, nothing added, not multiplied, just the base number and the power. Because once we get to that point, then we can use our logs. So what I'm going to do is I'm going to divide by 8,000. That's going to give me 2 here, and I'll have 1.04t. Then what I can do is I can take the log of both sides. So we'll do log of 2 is equal to log of 1.04t. Okay, keeping this going, same as we have here, log of 2 is equal to t log of 1.04, and this is the rule that we keep seeing, that idea that if we have the 1.04 to the power of t, that we can bring the t down to the front. If I continue it up here, we get then that t is equal to log of 2 over log of 1.04, and I get then that t is equal to log of 2 over log of 1.04, and I get an answer of 17.67, which we would round up to about 18 years, because remembering that t is the time in years, so we'd probably round it up to the closest one there, because it's not 17 years won't be far enough, so we'll round up then to 18 years. Okay, so we see in that one, that same idea, find the initial one, find the value after a certain amount of time, and that kind of idea. Let's move on. I'm going to skip over that one. I'm going to look at this one here. Question 13. So if we learn a skill and don't practice it, it gives us a particular model on how that works. It tells us A is a measure of how well the skill can be done at a certain time, B is a measure of how well the skill can be done t months later, so let's take note of that it's in months, without practicing, and C is a constant. So we're asked to write C in terms of log 10 of A, log 10 of B, and log 10 of t plus 1. Okay, so same thing as we've had before. If we look at the question here, we have A is equal to B t plus 1 to the power of c. And we are going to be introducing logs, but in order to introduce our logs, we would like to get to a point where we have the base, which is t plus 1 to the power of c, and that as our only thing on the right hand side, or on one side. Okay, we'd like just base and power, and then we'll introduce our logs. So to do that, I'm going to have to divide by b, and that will give me t plus 1 to the power of c. Once I've done that, I can take my log of both sides. Okay, so let me just set that up for myself first. I'm trying to just use a different color again, just to make it as clear as possible. So a over b, t plus 1 to the power of c. My next line, keep this the same, a over b, no problem, c log t plus 1. Okay, again, remember we're trying to get c. We're trying to write everything in terms of c. So I'll have log, and excuse me here as well, just to make sure we're definitely following the question, we'll use log of 10. So even though it's the same, even though we know that log without any number written there, without any base number written in, is the same as log base 10, we'll just maybe keep it the same since the question has specified log to the base 10. Okay, so just keeping it as same as possible. And the other thing we can do as well, because we're asked to write it in terms of log 10 of A, log 10 of B, log 10 of t plus 1, is on the left hand side we can split this up to get log 10 of A minus log 10 of B. That's equal to c log 10 of t plus 1. And finally that gives me that c is log 10 of A minus log 10 of B all over log 10 of t plus 1. Okay. A student got 80% on a guitar exam. 2 years after not playing the guitar, the student got 47 on the same exam. So let's use this information. So we have to be sure that we're using it appropriately. Okay, so A, we were told, was the original measure of how well the skill can be done. So A in this case is going to be 80% or 0.8. B is the measure sometime down the line, which is the 47% or 0.47. T was the time in months, so 2 years is 24 months. Okay, and once we have all this information, we can use this to find C by just subbing in to what we got as our answer for the previous part. So 0.8 minus log base 10, 0.47 all over log base 10 of C24 plus 1. Okay, and again, we can just simply do that in our calculator. And we get an answer of 0.165. Okay, to 3 decimal places, 0.165. Okay, let's try one more of these, and this is a good one, similar to one actually that we looked at in class to do with preparing food for a baby. We looked at one that was to do with milk. So Kieran is preparing food for his baby and must use cooled boiled water. The equation y equals a e to the power of kt describes how the boiled water cools. In this equation, t is the time in minutes from when the water boiled, y is the difference between water and room temperature, and a and k are constants. The temperature of the water when it boils is 100 degrees Celsius and the room temperature is a constant 23 degrees. Write down the value of the temperature difference y when the water boils and find the value of a. Okay, a lot of information there. So let's just have a look, because this is quite a typical question. As we see, it was an exam question from a previous year. It's quite a typical one as well. So if we look at it, we have our formula here. We're told t is time in minutes. Y is the difference between water temperature and room temperature, and a and k are constants. So if we're told that the temperature difference, we're asked to find the temperature difference when the water boils. So it's going to be 100 minus room temperature, which is 23, and that's going to give us a value of 77 degrees Celsius. So that's y. So let me set that equal to y. And now we want to find the value of a, so we can use the formula AKT. And what we know is that 77 degrees happens when time is 0, when the water is just boiled. So t was the time from when the water is boiled, but at the time that it's just boiled, when time is 0, the temperature is going to be 77. So 77 is a e to the power of 0. We should know that anything to the power of 0 is just 1. So I get that a then is 77 degrees Celsius. After 5 minutes, the temperature of the water is 88 degrees. Find the value of k. So first of all, y is the difference in temperature between the water and room temperature. So 88 minus 23, and that gives us 65. Then using my same formula as before, kt. So we know what that a is this time. We know it's 77 e k to the power of t. And we can sub in these other values as well. We can sub in the 65 for y, and we know that this happens after 5 minutes from what we're told up here. After 5 minutes. So 65 is equal to 77 E5K. 65 over 77 is equal to E5K. Once we've gotten this far, we can take our log of both sides. We might use ln this time. We saw this in class as well, why we might take ln for this type of question. And it's to do with, of course, what we have in the question. So ln of 65 over 77 is equal to 5k ln of e. And again, we should know that ln is the same as log to the base e of e, which means that it's the same as 1. And if you forgot that, you could try it on your calculator. It wouldn't make any difference. You'd still follow the same way, and it would still just work out for you, okay? So what we have then is that ln of 65 over 77 is equal to 5k, which means that k is equal to ln of 65 over 77 divided by 5. And we can just slot that into our calculator then to work out what it gets us. So if we do that, we get an answer of minus 0.0339. And we asked to 3 significant figures, so that's perfect. 0.0339. Kieran prepares the food for his baby when the water is cooled to... Okay, I haven't put in a percent. I haven't put in an actual temperature. So prepares the food for his baby when the water is cooled to a certain temperature. How long does it take, correct to the nearest minute, for the water to cool to this temperature? Okay, so obviously I've made a bit of a mistake when typing that in. I've just deleted the temperature out of it. We can pick a temperature. So if he's boiled the water and he's going to make it when it cools to a certain temperature, so we can pick a temperature. Say we said that he's going to make it when the water has cooled to 50 degrees. We'll say 50 degrees Celsius. Okay, so the difference is the difference between that temperature and room temperature. So 50 minus 23, and that gives us an answer of 27. So what we have this time is that 27 is 77 e to the power of kt. And again, we actually do know what k is there, so we can sub that in as well. So minus 0.0339 t. And once again, we're looking for this value of t. So we want to get on the right hand side just the base and the power on their own. Just so we have e to the power of minus 0.0339 t is equal to something. So we'll divide by the 77. I'll get 27 over 77 e to the power of minus 0.0339 t. Then same as in the last question or in the last part, I could take maybe the ln of both sides, just because I know that it works well with when I have base e. And I get e to the power of minus 0.0339 t. My next line, I can follow that same rule that we've been doing with nearly every question that we've looked at, taking down that power and leaving with ln of e. We know that ln of e is just the same as 1. So what I'll be left with is just 0.0339 t, and t then is ln of 27 over 77 minus, or divided by minus 0.0339. And again, we can put that into our calculator to see what we get out. So 27. An answer of 30.91. 30.91, so remembering t was the time in minutes. Yeah, the time in minutes. So around about 30.91, and we're told for the nearest minute, so it's probably going to be 31 minutes then. So if it's 30.91 minutes, he's going to have to wait till that 31st minute then to give it to the baby. So obviously I just picked a number there for the last question just to give us an example that we could look at, but you can see that there are a lot of similarities in how these questions are phrased and how we approach all these questions. So really we end up with a log equation, so converting an exponential to logs and then solving a log equation is typically what happens with all of these questions. So it's important to be familiar with moving from exponential to log form and just being confident with that, being able to take a question from this point here and to continue it down and make sure that you're happy solving for that variable in the power, so solving for t or solving for x or whatever it is. And we saw even at the start that idea of finding the 77, finding that initial time. So remembering that initial obviously is the time when time is 0. What is the value when time is 0? And those sort of things are really, really important. So those were all the word questions that were in your worksheet. I think that was all of them looked at there. So just making sure that you're happy with those ones particularly, because I think those were the ones maybe causing some issues today. There were some nice equations and things in that worksheet as well for you to look at and to look at the solutions for, just to give you a hand. But I'd focus on what we've done in class, focus on the examples and the questions that we've done. Some of these questions sort of push you on a bit further. This first page on moving from exponentials to log is a nice kind of start, and then it's just equations and things like that, pushing you a little bit further, and maybe just testing your understanding, and maybe bringing in things that you've already worked on before, different elements that you've worked on in previous chapters, and just testing, are we able to bring those and connect them to logs as well. So I'd focus on those ones. You can look at the solutions, and as I say, if there's any questions, then we can discuss them, or you can let me know and we can see if we can clear things up. But yeah, so just make sure you're looking at the solutions, just make sure you're working from those, but not just copying them down. Give the questions a go and then try and follow them back. So even with these ones here, just it's about having a go at them and then seeing, can you definitely follow them? Could you be able to follow them for yourselves and pick them for yourselves, and try some exam questions then for yourself if you really want to. You could, that's somewhere else that you could look to see that style of question.